The Chatelayer principle. According to Chatelayer principle, if any one of the variables like concentration, pressure, or temperature is changed, the system adjusts itself to cancel, to annul, to nullify the change in the variables. The different variables, the factors which affect an equilibrium are, we have seen, concentration, temperature, and pressure. Pressure has role mainly in the case of gas phase reactions. We have seen the action of concentration. When concentration of the reactants is increased, the forward reaction increases and more products will be formed. On the other hand, if concentration is of the reactant is decreased, the backward reaction, the reverse reaction takes place, and the production of a product that is decreased. We have seen an example with a ferric ion and the thiocyanate ion with the formation of a blood red coloration. Now let us see the role of pressure in the equilibrium. Pressure, action of pressure, the variation of pressure at equilibrium. You know, pressure has role only if there is gas phase reaction. Gas phase reaction. Suppose we increase the pressure, then what will happen to the volume? Do you remember the Boyle's law? Boyle's law, pressure and volume. When pressure increases,
Temperature decreases. Volume decreases.
pressure increases, volume decreases. Volume decreases. And therefore, when pressure is increased, the equilibrium is shifted to the side where there is lower volume. We have two sides, that is the reactant side and the product side. And which side is having lower volume? Lower volume. See, the side where there is less number of molecules, that side is having lower volume. And so when pressure is increased, volume decreases. According to Boyle's law. And therefore, the equilibrium is shifted to the side. The equilibrium is shifted to the side. Where there is a reduction in volume. Side with a lower volume, smaller volume. To that side, the equilibrium is shifted. And which side is having lower volume? The side in which there is less number of molecules, maybe reactant or product, doesn't matter. The side with less number of molecules, that is having lower volume. So less number of molecules, that is the side with a lower volume. So the equilibrium is shifted to the side with less number of molecules when pressure is increased. We are increasing the pressure. When pressure is increased, equilibrium is shifted to the side with the less number of molecules. Equilibrium is shifted to the side with the less number of molecules, and vice versa. That is, when pressure is decreased, volume increases, and equilibrium shifted to the side where there is a, say, higher volume. That means more number of molecules. Okay. Let us take our Haber process. That is N2G, only gas-phase reaction, plus 3H2G, reversibly giving 2NH3G, 2NH3G. It's a gas-phase reaction. You calculate the number of moles on the left-hand side, on the side of the reactants, the total number of moles. N2 means 1 N2. So 1 plus 3, that is a total number of molecules on the left-hand side. On the right-hand side, 2 NH3, 2 ammonia molecules. So total number of molecules on the right-hand side is equal to 2. Okay. Now, this is our Haber process for ammonia. Now, if pressure is increased in this reaction, if a pressure is increased, to which side the equilibrium is shifted? You say, Sania, to which side equilibrium is shifted when pressure is increased?
2NS3.
Saying anything?
2NS3.
Okay. Pressure is increased, the equilibrium is shifted to the side where there is less number of molecules. That is the side of ammonia. So in the Haber process for the synthesis of ammonia, high pressure is favorable. High pressure is favorable because the formation of ammonia is a reversible reaction. It's a reversible gas-phase reaction. And when pressure increases, the equilibrium is shifted to the side where there is less number of molecules, that is to the side of ammonia. So more ammonia is produced. So high pressure is favorable in the synthesis of ammonia from nitrogen and hydrogen by Haber process. In the Haber process, high pressure is favorable because when pressure increases, the equilibrium is shifted to the side where there is less number of molecules. That is the less number of molecule means ammonia side. So more ammonia is produced. When pressure is decreased, the production of ammonia decreases. That means ammonia is decomposed. There is a decomposition of ammonia. We need the production of ammonia. We are going to produce ammonia. So to get more and more ammonia, a higher concentration, a better yield of ammonia, it is a high pressure favorable. High pressure. So that is the application of pressure in the equilibrium. And this is according to the layer principle. Okay. Now let us think of temperature. What will be the effect of temperature on equilibrium? Temperature. You know, in a reversible reaction, if one reaction is exothermic, the other reaction is endothermic. Suppose R reversibly giving P, R giving P. Suppose it is exothermic, then P giving R is endothermic. It will be endothermic. In a reversible change, if one reaction is exothermic, the other is endothermic. For example, if the forward reaction is exothermic, then the backward reaction is the reverse reaction is endothermic. Okay. Now let us think of the role of temperature on equilibrium. You know, endothermic reaction is the one during which heat is, come on, Vidur, endothermic.
Absorb. It is
During
absorb. Heat
Heat
is
is
absorbed. Absorbed.
okay. I don't hear you. So endothermic reaction. Heat is absorbed.
Absorb.
Heat is absorbed. Exothermic. Heat is released, given out. So when temperature increases, say temperature increases. That means the mixture is heated. Which reaction is increased? Achyut, endothermic or exothermic? Achyut, which reaction will be increased? When temperature is increased, it is heated. Which reaction? Endothermic or
Exothermic.
exothermic?
Exothermic.
Exendothermic.
Exothermic.
What do you say? Exothermic.
Yeah.
Is it? What is exothermic? What is exothermic?
Release.
Heat is
Release of heat.
heat is given out. And if temperature is increased, what will happen? Say the reaction to occur, heat is to be removed. Heat is to be removed because it is exothermic. So the reaction occurs in the reverse gear. So when temperature increases, the reaction in which heat is absorbed, that is increased. When temperature is, there is a simple logic, very simple logic. When temperature increases, the reaction in which heat is absorbed, that is increased. That means endothermic reaction, endothermic, endothermic reaction, endothermic reaction is increased. When temperature is increased, endothermic reaction is increased. Maybe to left to right or right to left, whatever it is, endothermic reaction increases. On the other hand, when temperature decreases, just the reverse. Exothermic reaction, exothermic reaction is increased. Exothermic reaction is increased. To increase the exothermic reaction, to increase the exothermic reaction, the temperature is to be lowered. The temperature is to be decreased. Temperature is to be decreased. Then only exothermic reaction will take place at a faster rate. On the other hand, to increase the endothermic reaction, the temperature is to be increased. You fix it in your mind. You fix it in your mind. We need this always. Wherever you study chemistry, this is needed. Exothermic heat is released. And that is increased by a decrease in temperature. Decrease in temperature. Temperature is to be lowered. Okay. It is to be cooled. The reaction mixture is to be cooled. Then endothermic heat is absorbed. Heat is to be absorbed. So it needs heat, more heat. So to get more heat, the system is to be heated. That means temperature increases. So make sure that when temperature increases, all of you are there or not. Let me see whether you are there or not. Let me see. Okay. When temperature increases, which reaction increases? Vidur, temperature
Endothermic.
increases.
Endothermic.
No,
Endothermic.
it is not add. Okay. When temperature increases, endothermic reaction is increased. Endothermic. While when temperature is lowered, Adul, temperature is lowered. Anthony,
Exothermic.
when temperature exothermic reaction is increased. Exothermic reaction is increased at a lower temperature. Okay. So you Always keep in your mind this. And we need this for the second year also, not only for second year, wherever you study chemistry, and thermochemistry, this is needed. Okay. So when temperature increases, endothermic increases, exothermic decreases. And to increase the exothermic, temperature is to be lowered. You fix one. You fix one. The other one will be in the reverse order. Okay. So you fix like this. Temperature increases, endothermic increases. Is it clear? Temperature increases, endothermic increases, and vice versa. And vice versa. What is vice versa? Eh? When temperature decreases, exothermic increases. Okay. So endothermic increases when temperature increases because heat is absorbed. Okay. Now let us see the application of this in a reaction. So for example, you take the Haber process, the same Haber process. Say N2G plus 3H2G reversibly giving 2NH3G and delta H is equal to minus 92 kilojoules. N2G plus 3H2G reversibly giving 2NH3G delta H is equal to minus 92 kilojoules. Here there are two reactions. Now you say which is the exothermic reaction and which is the endothermic reaction. Which is the exothermic reaction? Exothermic, Sania, Adul, which is the exothermic reaction?
Forward reaction.
Exothermic. What will be the sign of exothermic reaction? Delta H sign of a delta H. Exothermic.
Negative.
Eh? Sign of a exothermic reaction. Now, let us go to the given reaction. That is our Haber process. Now, Anthony, you say which reaction is exothermic, which is endothermic. Which is the exothermic reaction? Here there are two reactions. Look at the board. Look at the board, there are two reactions. The forward reaction, forward means left to right, left to right, reactant to product, reactant to product. That is the forward reaction, forward reaction. Which is the forward reaction here? Forward reaction is N2, look at the board, N2 plus 3H2 giving 2NH3 delta H is equal to minus 92 kilojoules. That is the forward reaction. So what will be the backward reaction? Backward reaction, the reverse reaction, 2NH3, 2NH3 giving N2 plus 3H2. Delta H is equal to plus 92 kilojoules. Plus 92 kilojoules. And that is the backward reaction. So the forward reaction is exothermic. Forward reaction is exothermic. And what is forward reaction? N2 plus 3H2 giving 2NH3. That is the forward reaction. And it is exothermic. Exothermic. So formation of ammonia. Formation of ammonia. Is it exothermic or endothermic? Anthony? Formation of ammonia. Is it exothermic or endothermic? Are you sure? Are you sure? Say, ammonia is formed during the forward reaction. All right? You follow what I say? Ammonia is formed during the forward reaction. And here the forward reaction is exothermic. Why? Delta H is negative. Delta H is, you need not to study the value, but you have to remember the sign. You remember the sign. You just forget the value. Doesn't matter. But you have to remember the sign. That is important. So, formation of ammonia is exothermic. So, if temperature is increased, what will happen to the production of ammonia? Will it be increased or decreased? Atul, can you guess? Can you guess?
Decreased, sir.
Okay, it is very safe now because I cannot hear anything. It's all right. So, when temperature increases, the production of ammonia decreases. Decreases. Why? Production of ammonia is exothermic. Minus, delta H minus. Production of ammonia is exothermic. Exothermic change decreases when temperature increases. So, when temperature increases, the exothermic reaction, that is production of ammonia, decreases. On the other hand, if temperature is decreased, endothermic reaction, endothermic, sorry, when temperature is increased, exothermic reaction, did I say it wrongly? When temperature increases, exothermic decreases. But I said the same thing. Or did I commit a mistake? When temperature increases, exothermic reaction decreases. Here, production of ammonia, forward reaction, exothermic, and so it decreases. So to get a better yield of ammonia, what should be the temperature condition? Temperature is to be increased or lowered, decreased. Punya. Temperature is to be increased or decreased to get a better yield of ammonia. Ammonia. What is the temperature?
Decreased.
Temperature is to be decreased. Decreased.
Decreased.
Because formation of ammonia, we are going to produce ammonia. We are going to manufacture ammonia. We want ammonia. So to get a better yield of ammonia, temperature is to be better lowered. Say a lower temperature is favorable for the production of ammonia. But if temperature is increased, the backward reaction, that is endothermic, backward reaction increases. That means decomposition of ammonia. Decomposition of ammonia, forming nitrogen and hydrogen, that increases. That means the yield of ammonia decreases when temperature is increased. So to get a good yield of ammonia, temperature is to be lowered. Say application of temperature on chemical equilibrium. Okay. So we have seen the application of a Le principle on equilibrium, change in concentration, change in pressure, change in temperature also. Now let us think of one more factor, that is catalyst. Catalyst. What is the role of a catalyst? Catalyst, role of a catalyst in equilibrium. In equilibrium condition, what will be the role of a catalyst? What will happen? Equilibrium, role of a catalyst in equilibrium condition. You know, catalyst is a substance which increases the rate of a reaction usually. Usually, we'll study it later. Don't worry, you need not write it now. So, A catalyst increases a rate of reaction, the rate of reaction usually. Here, in a reversible reaction, the catalyst increases the forward and backward reactions to the same extent. It increases the forward and backward, both reactions. The rates of forward and the backward reactions. Rates of forward and backward reactions will be increased or increased to the same extent, increased to the same extent. So, catalyst has no particular role on an equilibrium. The equilibrium point is not affected by catalysts. The only thing is this: the equilibrium can be attained faster. Equilibrium can be attained faster. That is the only benefit of using a catalyst in a reversible reaction. In a reversible reaction, remember, next year, it's a must. You must give the answer, not to me, any teacher who is taking the class. So in a reversible reaction, I say in a reversible reaction, a catalyst increases the forward and the backward reactions to the same extent. Increases the forward reaction and increases the backward reaction to the same speed, to the same extent. So what happens? The equilibrium point is attained sooner, faster. We can save time. We can save time. The equilibrium point is not affected. The equilibrium constant is not affected. The equilibrium constant depends only on temperature. Equilibrium constant, remember constant, not the point. Equilibrium constant depends only on temperature. So a catalyst will not affect equilibrium point. It will not affect equilibrium constant. It will not affect equilibrium concentration. It will not affect the equilibrium concentration. The only thing, the equilibrium is attained very soon if a catalyst is used. And we can save time. And that is the only role of a catalyst on an equilibrium reaction. Okay. That is about a Le principle. There is one more point we have to study in this chapter, and that's about acid, base, and salt. Salt we need not study too much, but we have to study about the acids and bases. So let us begin with the acids, bases, and salts. It's very simple. And salts. Oh, you have studied this in the 10th standard. Acids, bases, and salts. Right? Studied in the 10th standard. There you have studied acids are hydrogen ion donors, H plus ion donors, while bases are hydroxide ion donors, OH minus ion donors. Am I right? Is it right? Do you remember? Acids are hydrogen ion donors, H plus ion. Acids dissociate in water, in solution. Acids dissociate in solution, forming H plus ions, hydrogen ions, protons. While bases, they dissociate in solution with the formation of hydroxide ions, OH minus ions. That is why I told you that acids are proton donors, hydrogen ion donors, H plus ion donors in solution. While bases are hydroxide ion donors, OH minus ion donors in solution. And this is an old concept of acid and base. The very old concept of acid and base. And this is due to Arrhenius concept of acid and base. Now, I'm going to take only the Bronsted theory of acids and bases, or a Lowry-Bronsted theory. Lowry-Bronsted theory, or simply the Bronsted theory. So one Lowry-Bronsted theory, Lowry-Bronsted theory. It is also known as the protic theory, or a protonic theory, or a protonic theory of acids and bases. Here, Lowry and Bronsted, they define acids and bases based on protons, H plus ions, protons. Here, acids are proton donors. They are same definition. Proton donors, hydrogen ion donors, H plus ion donors. So they are acids. That is the Bronsted theory. We call it as the protic acid. The acid that provides, that gives proton. The acid that gives proton in solution. That is called the protic acid. You take hydrochloric acid, HCl, in water. It ionizes to H plus and Cl minus ions. HNO3 ionizes to H plus OH minus ions. See? No, HNO3, OH3, NO3 minus, NO3 minus ions, nitrate ions, NO3 minus ions. Okay. Sulfuric acid, H2SO4. Two-step ionization, first step, H plus HSO4 minus. So in solution, aqueous solution, there will be the formation of a proton, hydrogen ion, H plus ion. So all these are acids. HCl, HNO3, H2SO4, etc. are acids. You think of this ion, HSO4 minus ion, hydrogen sulfate ion, that can further ionize to give H plus SO4 minus 2 ion, sulfate ion, proton, hydrogen ion, and sulfate ion. So from HSO4, hydrogen sulfate ion, we will get H plus ion. So by definition, HSO4 ion is also an acid. Can you follow this? Acid need not be always a neutral molecule like HCl, HNO3, H2SO4, H3PO4, H2C2O4. No, it need not be always neutral molecules. There can be ions also. HSO4 minus ion. According to Bronsted theory, HSO4 minus ion is an acid. You take ammonium ion, NH4 plus ion, it ionizes, giving NH3 plus H plus ion. So from ammonium ion, H plus ion is produced. So by definition, ammonium ion is also an acid. So acid may be neutral molecules like HCl, HNO3, etc., or ions like HSO4 minus, NH4 plus, or HCO3 minus, etc. They are proton donors, and so they are protic acids. according to Bronsted theory of acids. Bases we can see in the coming class. Let me stop now. Thank you.